Hi there, and welcome to another Papetti Math YouTube video tutorial where I'm going to be teaching you, yes you, Algebra 1. And in this lesson we're going to look at linear regression, which is an area of statistics that's very useful. It says right up top that statistics are often used to create a mathematical model that is able to predict unknown values. This type of modeling is called regression. In order to perform a regression model, you must have a set of bivariate data, or data taken on two different variables. So bivariate means two different variables. There are several different types of regression models, but in this lesson, you will focus on linear regression, or models that resemble a linear function. Linear regression makes lines. So in exercise number 1, we have Mr. Freddo's ice cream shop analyzed its sales patterns based on the temperature outside. The results are shown in the table below. The first thing we want to do is we want to graph a scatter plot that represents the data on the grid below, and then after we graph that scatter plot, we're going to draw a line of best fit through the data. So let's first take a look at that table of data that we have over here. It's representing temperature and number of sales. And then we're going to look at our graph over here to come up with what we need to label each area of this graph, each axis on this graph. So let's start with the x-axis. And the x-axis is going to represent our temperature in degrees Fahrenheit. So we want to look for our smallest value here, and our smallest value looks like 48. So we might want to start at 40 or 45. And then our largest value in this table I see is 89. So we might want to go up to 90. So let's just try this out and see if we were to start at, let's make a break in our graph because this would be 0. And then we could go up to 45. Let's see if we could go 50, 55, 60, 65, 70, 75, 80, 85, 90 perfectly. Okay, so let's go up by 5s up to 90 over here. And again, if you chose a different scale on your axis, that's okay, as long as it fits your minimum and your maximum value. And I like to spread it out with this break because the more spread out a scatter plot is, the more accurate representation you can see the correlations. So we're going to go to 70, 75, 80, 85, and finally 90. And let me just double check. I don't have anything above 90, right? Nope. Okay. So now I'm ready for my y-axis, which is going to be our number of sales, as it's written over here also, so we know that's y. And our smallest number of sales looks like it's 20. And our largest number looks like 97. So we might want to start at 20 and go up to 100 to be safe. So let's see what we could do there. So if we start at 20 here, we could go 30, 40, 50, 60, 70, 80, 90, 100, and that works out perfectly too. So since I'm going from 20 to 30, and I'm going up by 10s here, and it's not going up by 10s here, I definitely do want a break there as well. So I'm going to go 20, 30, 40, 50, 60, 70, 80, 90, and 100. And again, we have that extra line there, so you could have just started at 0 and went 10, 20, 30, 40. Either way would have been perfectly okay. So now we're going to sketch our scatter plot. We can't plot exact values because we don't have the minor grid lines in between. So we're going to graph the point 80, 90 first. So we'll go to 80 and then up to 90. That one we could graph exactly right there. 71 is going to be an estimate, and 83, 71 to 83 will be about right here. We have 89 and 97, 89, 97. We have 60 and 50. We've got 78 and 88, 78 and 88 right here. 48, cold day, and 20 way down there. 65 and 52 on the line right about there. And finally 56 and 37, 56 and 37. So that's right there. So this is a scatter plot of actual temperatures on a given day and the number of sales at this ice cream shop. So you could right away look at this pattern and see that as the temperature goes up, so do the number of ice cream sales. That kind of makes sense because on a hotter day, you might want ice cream, but on a colder day, maybe not. So now the next thing this problem said to do was to draw a line of best fit through the data. So we're going to take our shape tool, we're going to insert a line, and we're going to draw a line of best fit through the data. So what we want to do is we want to draw a line that pretty much, let's see, has the same number of points above the line as below the line. That looks like 4 and 4. And it passes through as many as we can. Well, this one doesn't pass through any, but this one pretty much has 1, 2, 3, 4 points above the line and 4 points below the line. So this would be my line of best fit. And again, yours might look slightly different, but they should all be pretty much the same, in the same general direction going up. All right. So now it says in part B to use the linear regression function in your graphing calculator, find the equation of the line of best fit for these data. Explain what the slope of the equation represents in the context of the situation. So for this, you are going to need your graphing calculator. And we are going to be using that button that we used when we did the one variable statistics. The first button we learned about in the statistics unit was the stat button. And we are going to be editing our lists. And if you have anything in your list, remember to go up to the highlighted L1 section, highlight L1 by clicking up, and then clear, then enter. So now that we have empty lists, we're going to recopy this table of temperature and number of sales into list 1 and list 2. So in list 1, we're going to put our values of 80, 71, and 89. Then we have 60, 78, and 40. Oh, that was 48, so I want to go up and I want to edit that to 48. And then I have 65 and 56. 65 and 56. Now when we're ready to go to list 2, you just click the right arrow key and it will take you over to list 2. And again, we're just going to put the number of sales in list 2. 90, 83, 97. We have 50, 88, 20. And finally, we have 52 and 37. Now, if you put your data values in correctly, you should have these dashed lines lined up at the bottom, which means you have the same number of values in your list 1 as list 2. Now, we want to find our linear regression. So we're going to go back to that stat button, and we're going to go over to where it says calc. So when you go over to calc, you look down at your options, and this one says linreg ax plus b. It's very similar to mx plus b, which you learned about in the linear equations unit. So that's what we're going to choose. We're going to choose option number 4. You could scroll down and press enter on 4, or you could just press the 4 button. And then our X list is L1, that's correct. Our Y list is L2. We don't have a frequency list, and we're just going to go to calculate then. And when we press calculate, it gives us Y equals AX plus B. It gives us an A value and a B value. So based on this information, we have an equation of a line of best fit. So let's write that equation down. So we're going to write Y equals MX or AX. Instead of A, we will write, let's round this number, 2.02 to the nearest hundredth. So we'll do 2.02x, and then our y-intercept was minus 73.81. Okay. And the final part that we want to do with this exercise is explain what the slope of the equation represents in the context of the situation. So again, our slope is denoted by the change in y over the change in x. And if we remember our units, our y values were sales. So it's the change in sales over the temperature. So this number here would be 2.02, and that would be the unit rate of sales per temperature. But that sounds weird. So instead of saying per temperature, we'd say per degree. Okay, so for every 2, we're going to say 2, even though it's 2.02, because you can't have 2.02 sales. So for every 2 sales, the temperature increases by 1 degree. Or you could say that for every degree the temperature increases, there are 2 more sales. Because that's what this is pretty much saying, that this is 2.02 over 1, and for this slope right here, you'd have sales over degrees. So this would be 2 sales per degree Fahrenheit. So we have finished exercise number 1 on our first exercise on linear regression. And if this video was helpful to find out what linear regression was, how to draw a line of best fit, how to create a scatter plot, and how to use your graphing calculator to determine a linear regression equation, give this video a thumbs up, a like down below. You're now ready for exercise number 2, and you can click on the link right now.